Welcome, and good morning, and thanks everybody for making space in your busy schedules and agendas in joining us at our webinar today. Before we start, we have some housekeeping and three key announcements to make. You have been muted, that's the first one. So you ask, if you need to ask questions in the chat. And we have a dedicated time at the end of our webinar, at the end of the presentations for Q&A. And also a nice surprise for you at the end of the webinar as well. That will be then free of charge. So enjoy the presentation, enjoy the webinar, and looking forward to the end surprise. My name is Bob Rock, and at Datacentrics, I am looking after business development. And in the next half an hour or so, we will share with you few interesting stories about how we are helping our customers and how we can help you. The next slide, please. At the Datacentrics, we make data science and machine learning having a real impact on organizations around the world. Same as AI, ML, artificial intelligence and machine learning, we are grouped into 4 tribes. So you can imagine A stands for artificial, so not so artificial personas in the PX tribe, which is looking at personalizations for the banking and insurance. I, no doubt, is the retail. In retail, speaks for itself, improving the customer experience in all retail, FMCG companies, as well as e-commerce. The M standing for machine, that's our tech scale tribe that is looking after the platforms for AI applications. And about the tech scale, we will talk a little bit later in the presentation in more detail. And the L for learning, that is our R&D tribe, full of innovation, startups and solutions soon to be valued at billions and billions of dollars. Next slide, please. We partner with Microsoft, AWS, Amazon Web Services, and the key partner here for our presentation today is Databricks. And to be in the number 4, you see also the awards section here in the middle with the green, where we have been in the end of last year. We have been awarded by Deloitte, one of the leading and fastest growing companies in the data science space in Central Europe. For the customers, we have placed here some logos of 20 plus customers that, you know, if I divide it into those 4 years that we have been on the market, it's roughly on average about 5 customers plus every year that we help and that we support in their business lives. Thank you. On the next slide, please. Today, we will start with the best, helping the companies impacting their business. In discussions with our customers, we understand that the legacy, the on-prem or on-premises analytics architecture are no longer keeping with the current needs. That is, with the costs, with the agility, and the innovation. Therefore, our teams helping the customers to actually achieve all those, increase the revenue, lower the costs, and make the business efficient. The next slide, please. All this has obviously an impact on productivity, complexity, and effectiveness. And later on, we will give you more details and more use cases about where we are and what we do with the customers that we serve. And for now, I'll hand over to my colleague Oldřich, who is going to take you through a little bit of technical experience with Databricks. Thank you very much, and I'm looking forward to speaking with you a little later on.
Okay, thanks, Bob. And okay, so now we'll talk a little bit about the technical aspects of it, of the platforms, the migration process, everything. But I would also like to spend a lot of time talking about the implications, the context, both business, in how does technology impact the business, how does it impact the processes, how it can help them, how it can hinder them, which is what we want to avoid. And so let me first start by bringing to light the elephant in the room, the one thing that we're all here for, that one thing that we as a company want to do, which is data. It's been said, it's a buzzword all over, that data is the new oil, and it's true, and it's about using it. And what do we mean by data? We don't mean small data. It's surely there's some very powerful Excels in the world with lots of extremely useful information, but we're talking more about the big data, the data that comes from operating day-to-day, the day-to-day operations, from that comes in to your service, and also the same data that you might want to use to create machine learning. Experiments, and then productionalize them and use them to help you better understand your customers, to make smarter decisions, those little decisions that actually make a big difference in the end. But when we talk about big data, we usually in the same, it's usually said in the same maybe paragraph or at least a page, the mention of Apache Spark, because Apache Spark is the golden standard for processing large quantities of data, and it's for a very good reason. I'll talk about some of the reasons why I personally believe it's strong, but let's just say for now that it's the golden standard. But Apache Spark is still an open source technology. You could very well just run it yourself. You could easily, and this is the critical part. You could, start your own Kubernetes cluster and start Spark on there and run it, but it would take an upwards of 30 dedicated, highly technically skilled people to run this. So what you usually do is you're gonna want to delegate this responsibility to some kind of provider of managed Spark. And I would like to talk you through. One of the things I'll be talking about is why I think Databricks is the choice, why we've been working with them for a long time, and why we choose them as partners, and why we use that, resource, but it's much more than just a resource. And also some broader context. So one of the things that Databricks does and does well is it is the best, managed Spark. I'll talk more about some of the details. One of the things is performance, but there's all sorts of bells and whistles, which aren't actually bells and whistles, but are hugely important about this. But also, one of the things that I would really want you to take away from this talk, is it's not just about, having the data shovel and just moving data from one pile to the next pile. It's much more, it's about whole ecosystem, and I think Databricks understands this very, very well. And there's been some, issues that have risen up when you're trying to do something with data, when you're trying to build an actual use case on it and not just play around with it. There's some issues that rise up, and Databricks has come up with some technologies. One of them is mentioned on this slide. It's the Delta Lake. It's the Delta tables. a cool thing, you know, that gives you some more guarantees about your data, about its consistency and quality, but also about it's also come up with ML flow for productionalizing machine learning models and many more cool things. So it's a much broader context, and what I really like you to take away from this talk is that it's not just, as I said, it's not just, you know, moving large parts of data, although yes, Databricks I think is the best at this also, but it's also some, you know, there's some broader implications and some further context to be considered. And that's enough for this slide. We can move on to the next. And I would like to, you know, Databricks, you know, titles itself that it says it's a unified data analytics platform. I think it's very much true, and I will talk about that later when we go more into the tech stack, the unification of the technological stack. But also, maybe my point of view is that it's not just unified; it's also unifying, because when you're, you know, when you're working on some use case with data, the data is coming in, it's being ingested, you know, it doesn't matter, streaming service, whatnot, batch shops, you know, full loads of data, whatever is being processed, then, you know, hopefully some data scientist picks it up, because please, if you got data, just use it, it's there, it's yours, get as much of it, get as much out of it as you can. But then, you know, of course, there's some pipelines that need to be run that absolutely need to work, and those data engineers are working on it, and the infrastructure guys, of course, and the operations. But also, you know, there might be some use cases where data scientists come into play, and they start training some machine learning models on those, and they play around, and once in a while they come up with some brilliant model. They figure out that, you know, it gives good predictions and actually could be used somewhere, and they move it to production. And that's, you know, where it goes further into the operations, into the production where it runs, and so on. Now imagine if, and as I said, I've a bit more of a data science background. Imagine if the data scientist produces a model and then just, you know, throws it over the fence and says, hey, operations guy, this is your problem now. It's not going to work, because the models need to be retrained periodically, you know, daily, weekly, monthly, I don't know, depends on what kind of a business you're dealing with, what's the underlying data like, but it needs to be retrained. It's the data scientist's responsibility to be present in the retraining. Also, you know, if you're loading the data, you know, the data engineer is responsible for making sure the data are in their place at the right time and so on. And, you know, if that happens on some other system and then on some completely different system, the data scientist wants to use the data, how are they going to communicate? So I think this is where Databricks is really strong. I think it's, you know, to me, it's sort of, I tend to overlook this because I just think it's normal, but this is actually a big deal, you know. I really do think it's something that is very, very important, because from the technological perspective, you have one workspace where you can work in one place, one place, one workspace, in one engine with one API, in one programming language. Like, everything can come together and those people can collaborate. I think this is extremely powerful, you know. Of course, please, this is my subjective opinion, but like, you want to use Python for that, that's the one language I'm talking about. If you've got some data scientists straight out of universities, you know, or, you know, whatever it is, masters or doctors, you know, whatever, they'll probably know Python and they'll love Python and want to use it. You know, Spark has Python API, so you can actually unify the stack under one language and one platform. And this is really cool to me, and it's something that I tend to overlook, but it's actually hugely important. Of course, just because I talk about Python doesn't mean that other languages are not, supported. So if your data scientist wants to use R because he's got a background in statistics, whatever. If you've got some data warehousing guys and they want to work in SQL, they can. It's just that there's everything for you to, to unify all these people and bring them together. Also, as I said, it's not just about Python. Other things are supported. I know the Databricks is working on those SQL analytics platform, which I think is going to be quite cool, especially for data analysts, which is going to be awesome. And, as I said, all they have to do, since everything is in cloud, all they have to do is, it was like last week and this week, we've been working on productionalizing in Word2Vec model. Doesn't matter technical details, but I said, hey, just paste me the link. Copy the link, open it in browser, and I can start working with that person in real time. I think that's actually real strong. And one of the things that it does for you also is, because it's in this one workspace, nobody shuffles data around and so on. All this data can be securely held in one place where where all the best practices about security and data compliance are followed. So that's one thing. I haven't even mentioned much about analytical. I think also when we talk about Spark, it's the golden standard for big data processing. When we're talking about machine learning models, productionalization, MLflow is the golden standard again. MLflow is a project that was created by Databricks and open source, so you can actually run it yourself. The cool thing about it is both you can run it yourself if you want it, just like Spark, but in Databricks you get this out of the box. You just open the Databricks workspace and it's there, including UI and everything. So they've already have this integrated, and you can do all sorts of things. You train the model and you push it through the different stages, and you can do that, and you're already covered out of the box. So with that, I think we can move on to the next slide. And here, as I said before, on the previous slide, it was about how I think it's not only unified, but also unifying in terms of the people. But I want to talk a little bit about, how it's unified in terms of the technological stack. I think is hugely important, and this is where I'd like to talk more about the Delta or Delta Lake, not to be confused with the Delta Engine, unfortunately, and also some Spark capabilities and why I think I'll also talk about Spark later, but just some of the huge benefits of this. Okay, so Spark, one of the great things, of course, that it does for you is that it decouples the compute and it decouples it decouples the compute and the storage. And this is actually, when I first heard it, it was like, what's the big deal? But it's actually a big deal, because when you can do that, if you are using, you can actually move on to the pay-as-you-go model, and you can actually benefit from having cloud storage and so on. Because suddenly, when you have cloud storage, it can be, it doesn't matter if it's maybe some platforms are a little bit better for some specific things, but whether it's Azure blob storage, table storage, whatnot, or it's Amazon AWS S3. The thing that they have in common is storage is dirt cheap. If you get just data lying around, it's just dirt cheap. It barely costs anything. When you start using the data, it bumps up a little bit, but it's still pretty cheap compared to everything else. So unlike you might have some other file systems that they need the compute because the data is living either on the compute that is used for the computations, in which case you switch off the servers to lose the data, or the actual computation servers are are separate, but still the data lies on those servers that on some other servers that need to be active. In which case, you're paying for the compute. You have to pay for the compute. If you switch the compute off, well, if you don't switch it off, you're paying for it. If you do switch it off, you are, you lose the data, you lose access to the data. None of that is good. So in this case, one thing is you just have storage, you dump data on the storage, it's very cheap, it's awesome. And you can, I'll be talking about you can pull all sorts of data in there and don't matter. And the other thing, of course, compute. So we've talked about, in the picture, it's the data lake for all your data. That's the part I'm talking about. Now I'll talk about the compute engine, which is, in the picture, high performance query engine. We mean by that, now there is specifically the Delta engine. Now I might talk about that in a minute, but to me, that box should probably the most important thing is that it's the Spark engine, and it's the compute basically. That's the thing. And as I mentioned previously, since the compute, you only need the compute when you need it, and this enables you to fully utilize the pay-as-you-go model. I think this is an extremely important thing. Again, if you are on-prem, you need a big freaking cluster because you've got some big computations. You'll have to buy the computer. It's gonna take long. It's gonna take, and it's gonna sit there most of the time. In cloud, right? If either in cloud or if you have this full decoupling in the cloud, what you get is what you get is that you can switch it off and not pay for anything, and you can. Sorry. Sorry for technical difficulties. And if you are in the cloud, what you can do is if you are using it, you can for a short amount of time you can pay for a pretty big cluster. It doesn't cost as much, but at the same time you can switch it off later, so you're actually pay much less. So that's one thing, and it also enables you. It's not just that you pay less, but you can get to, I really need a big cluster right now because I've got a use case that needs it. I can get that within a matter of minutes, literally minutes. So we've covered that, decoupling. Now I'll talk a little bit about maybe let's say end-to-end on this picture. You can, we're talking about the technological stack, but also the process of how the data moves through the system. So we've got some data coming in. We've got some tabular data, rows, columns, just like in a traditional warehouse. It can be connected to a data warehouse, but it can also be images, some completely unstructured data. It can also be, semi-structured, some JSONs from a streaming service. It doesn't matter. The beauty of the data lake is that you can ingest all of it. You can just dump it to the storage and you can use it later, or you have something that, of course, if you need, some use case that needs to be running where you need the strong guarantees, then of course it's not just dumping it there. It's actually, you need it to perform and everything you can. You can absolutely do that. But that's where the Delta Lake comes in, because soon after people started using data for all sorts of purposes, ML, but also for just for pipelines, for ETLs, for making the big processing big data. What quickly became apparent is that unlike a traditional warehouse where you've got you've got strong guarantees on the consistency, on the schemas, on the everything, you had none of that in the data lake, which was awesome at first, but also you need something that it's a huge advantage. You're very flexible, but at a certain point, you'll realize that you will want some stronger guarantees. And another, Another proof that Databricks understands this landscape very well, and it's a platform that covers much more than just Spark, is the Delta. It's again, it has been open source, and it provides you with some stronger guarantees. Like it's basically a step from no guarantees to some level of ACID. For if we pick some jargon from maybe the data warehouse world, so it brings you some transactional qualities to the tables that you define on top of your storage, because of course what you want, those data scientists, we've got data science, ML, but also Power BI tools, and also analysts, everybody. What you want is some kind of abstraction, because you don't want to be picking up individual files from the storage and listing it. You just want to say, hey, I want top 1,000 customers, and give me this, statistic about them. I want select from customers limit 1,000, and you wanna do that. So that's why, of course, you've got some kind of abstraction, and Delta Lake, the abstraction is, of course, some putting some metadata around your data to say, hey, this is a table. This is actually, I want to look at it as a table, and this is what Spark enables you to do, of course. But the Delta doesn't do this. It adds additional properties to it, like the transactionability. Okay, with that, we can move on to the next slide, please. And here there's several lines, punch for punch, technology for technology. What I want to look at first is that it's not just I don't want to look at it punch for punch, technology for technology. What I want is some high-level overview. If you look at the left, there's basically a technological use case, and either platform, tool, framework, whatever. On the left, there is a whole zoo of stuff, right? And on the right, it basically says, there's some differences in each line, how it's worded, but basically it says, use Spark on Databricks in notebooks. That's it. And this is actually true, because when I work, it doesn't matter if it's a streaming job, if it's some streaming table. I'm gonna define it the same way, using the same API in the same place as if I were doing a batch processing. It's actually the same. There are some differences, yes. Some commands cannot be used on one or the other, but basically it looks, feels, and is the same. And also, if I'm training a machine learning model, I don't need to go to a different platform. I use the same API to load the data, and in Spark, which is the data frame API, which is a structured API, and I can just as easily just use the Spark ML lib and start training the models. And I think this is also hugely important. You can view it from the technological perspective and say that you do not have as many tools, platforms, and whatnot to manage. So it's definitely going to be something about the operations cost in terms of, it's just going to be much easier to manage and just and operate. And the operations cost, of course, that you just have one platform that you need. And also, you could reuse the resources and so on. But also, it enables you to have some kind of communication, right? We come back to the processes, because if you I'll be honest here, if you tell a data scientist to write a MapReduce job in Java, he's gonna run the hell away in terror. That's just gonna happen that way, or he's gonna cry, or both. Most data scientists, at least. So if you can do all this in Python using the data frame API in one place, which is Databricks, then you get it easy. Instead of I want to do some machine learning, I'm gonna do on the left we got ML, yes, use Spark. But if I want SQL, I would have to go somewhere else. If I wanted if I wanted batch process, because I don't have all the data I need to prepare some tables, I would have to if I had to write MapReduce every time I had to create a new feature, I would cry. I can tell you that much. So this is one of the things that I think is hugely important. You can get all of these things using the Spark. And here's the surprising thing, because usually when you have a very generalizing technology or process or anything, it's going to suffer. It's going to be much more general and much more useful in broader areas, but it's going to suck at each individual one of them. The surprising thing is that Spark actually is able to cover several different areas while being more performant, because I think this is a testament to the quality of the abstraction provided by Spark. It's the data frame API, or more general, the structured API, is actually a good abstraction. And one of there's technical reasons for why it's more performant, or why it's just better and easier to use. You just write something that is akin to SQL statements. Under the hood, there's a whole bunch of optimization going on that's gonna take your code and make it faster. So there's the catalyst, there's the Kingston, and so on. I don't want to go into the details. So this is actually a huge deal, because it enables people to write queries simpler in a unified way. And the queries are actually going to run faster, which I think is an actual killer. And with that, we can move on to the next slide. And now I've been talking about the data landscape in a way, how I see this particular piece of it, some little bit of broader context. But this is a webinar, of course, about migration. We gotta talk about why you might want to move, but also how you can move. And I would like to set some expectations, because I think that it's important to set expectations to understand what we're talking about. Because if we talk, there are some differences. If model example, if you are already in one Spark, or in a different Spark runtime and a Spark, I don't want to say flavor, but a little bit different, a Spark on a little bit different platform is gonna have some little bits and pieces of differences, but it's still gonna be Spark. If you take this solution and all you want to do, and you're already running in cloud, that's important. Like if you're already in cloud, already in some kind of Spark, and all you want to do is take your solution and move it over to Databricks, it's actually surprising, but technologically we can be talking just a few weeks. Migrate. Choose a works. Choose one use case. You don't have to migrate everything all at once. I think that's the fail fast strategy. I think incremental process is much better. So you just, hey, we want to try it out. We already are in cloud. We're already in Spark. All we want to do is take this, move it. It can be done with a couple of weeks. It's actually quite surprising how fast it can go. But of course, as I said, it's about setting some expectations. So one of the things to consider is, are you migrating from cloud, or are you migrating from an on-premise solution? That's actually, I think, a huge deal, because if you're already in cloud, it's not so much that technologically it might be harder, although it might be, but it might not. It's that if you are already in cloud, many of the discussions about data security and data governance, data compliance will have already been had. That you will have already had those discussions happening, or they have already happened. So there might be some additional discussions. Are Databricks secure? Yes, they are. Also, how they approach all those different things. What are the things that they offer? So yes, there might be some additional discussions, but the bulk of those discussions will have already happened, hopefully. So that in that case, it might be much easier to do in terms of the things around the actual technical part. But if we're talking on-prem, then what's going to happen is there's going to be a lot more, there's going to be a whole bunch of discussion with the security guys, with the data compliance guys, with all sorts of different people and what's the word I'm looking for? Departments. All sorts of different people and departments, and in which case you need a conversation partner to help you with this, which I think is going to be, just the same way with the technology. If you know what you're doing, you can do it in a couple of weeks, and all you need basically is a tourist guide. The same thing I think will apply for the process, that there can be somebody who can help you with the discussions. And this is as for us, I think FOF is going to have further down the line some calls to action. But I think if you want to reach out to us and have have some discussions, help you assess what you currently have, how you're using your data to generate some business value. Whether all these different discussions, either technical or process-wise, will be more than happy to help with this. But again, setting some expectations. So we've talked about the difference, cloud or on-prem migration. It's just not a some kind of like let's just do it. There is some assessment that needs to be done. You need to look at the individual data, how sensitive are they, what's the size, all those different things. What's the workload? What's the jobs? Is primarily batch job, streaming jobs? What's the orchestration of those jobs? What's the tools? Security and governance absolutely needs to be discussed. That's a big deal. That's of course that's one thing that absolutely needs to be discussed. Some other tools, are you taking some? Are you how much of the solution can just be replaced, with Spark or Databricks? Are there some things that you might want to look at, additional services in the cloud that are going to that you're going to supplement the solution with? Because, or as I said, it's about a whole ecosystem. It's about a broader platform. It's not just one thing. So that's one of the things. And again, as I said, setting some expectations. There's a big difference between lift and shift and transformation. Or the words or buzzwords, I don't know. But in reality, what you want to ask yourself is, do I want just move the workload to Databricks, just try it out, see how it goes. No big refactoring, no big changes. I just want to take the solution as it is, move it, and see that it runs the same way that it did before. I don't have much, expected. In which case, this is much faster, much easier. But also, there has to be some expectation. You are not going to see some crazy improvement in performance, because, well, there will need some kind of tweaking, and that is the other option, transformation. If you want to take the workload and spend a little bit more time, in order to get much more performance. Okay, since we're running out, running a little bit low on time, I'll just take it a little bit quicker. We can go on to the next slide. And there is some. This is a migration. I'll not go into details because NDAs, because all those things. I was part of this migration in shadowing as a shadowing. As I said, the improvement gains. This was I think it was more of a lift and shift. It was just take the solution, make it run. Yes, it was about making it faster. It took a couple of weeks, but I was very pleasantly surprised that just a couple of changes. They changed the format to Delta, and suddenly, as you can see, they've got 98% data compression. It was running much faster, and so on. So that's all I wanted to say. It was just It depends on the latency to transformation, but you can see some improvement gains right out of the box because of a better query engine and so on. And we can move on to the next slide, which is just an overview. You're not alone in migrating. There is a whole bunch of companies going through such change, and as Bob already mentioned, we are working with a whole bunch of companies on bringing more value from their data. Also, Databricks that we partner with. There's a whole bunch of this, so there's a whole bunch of know-how on how to do these things. So yeah, we can go on to the next slide, please. And I'll just skim through this very quickly. What's important is there are some obvious costs, like less spend on infrastructure. That the clusters don't need to run all the time. They're more performant. They run faster, so it takes less time, so you pay less, of course. And there's the increased productivity. Sure, that's usually important. But I think that's something that needs to be mentioned, and I think that some hidden and hard to discover costs, too, that I think are worth to mention, because they might be the little things that get you in the end, or some things that are very hard to see. And there's like three things that I would like to that I ask myself, like I would ask myself, like, do you want to have the best technical people working on fixing the platform, or working on your actual problem, generating some value? And this is, Databricks, I think, this like Databricks all, and Bob will talk about the further context and how we approach this, but what you want is something that you'll get a lot out of the box, and where you can dig deeper and make it customize it to your particular use case. But you don't want to just spend countless hours and many technical people on just fixing a broken an environment that is just by design very hard to manage, where you can apply those same technical people to much better use to actually generate some value. Another thing that I think is hard to measure, especially if you're on-prem, I honestly don't know how long it takes to provision a new computer, but I don't think it's gonna be in a matter of minutes. It's not gonna arrive in a matter of minutes. It's probably gonna be much longer. In cloud from Databricks, I want new cluster, 5 minutes, like 5 max 10 minutes to get a new cluster, to get it running, and I'm good to go. So this is the thing, that there's some time before you start working. If you see some use case, if you see some opportunity, it takes you half a year to start. It might already be too late. So that's another thing. And as I was mentioning, communication. Whenever people are involved, it's about communication. What's the price of your different tribes or different departments not being able to talk the same language? It might be the difference between delivering a solution or not delivering a solution. And I think, it's not just efficiency, it's about actually delivering. And I think that is, and that's where we want to have real impact on the business, and this is where I'll pass it back to Bob.
Thank you very much, Olzik. Excellent stuff. I think in the normal world, it takes days, probably weeks to provision a computer. Definitely, it is not a matter of minutes, as you have described on this on your slide and in your discussion. On the next slide, you will see a real-life example of one of the Databricks customers from the telco environment, who have actually engaged in the migration to explain what all of this mean to you. What basically Olzik already mentioned, that with the on-premise solution, that arrow that is going right through the floor, the red one, that is the Cloudera on-premises costs as they were calculated over a period of 3 years. So you've got 12 quarters of costs running through the data center cost, the admin cost, and then the new hardware and licensing. All of that is amounted to nearly $19 million. The Databricks investment was roughly about fourth quarter, 25% with the usage, support, migration, and the cloud compute. That was sort of also very steady over the 12 quarters over the 3 years. The value that one gets from Databricks is in that avoiding the licensing part. So you can work also with pay as you go, and you are billed exactly for what you use. That's the subscription economy. That these are the benefits from cloud. So you don't need to add any additional expensive hardware if you need, or as you need, additional capacity to work. That's on this slide. On the next slide, I will talk a little bit about these were the Databricks value, what you have seen, added value to your organizations. Now the value that you will get from Datacentics is not only in our data science experience. We are at a European Center of Excellence in AI and machine learning, in data science in general, with 40 plus data scientists and 40 plus data science engineers who also help with business use cases, and we are presented endless customer use cases, as you can see here on this slide. The business use cases are clear for this particular area. That's for our in retail tribe, where we offer, and this is only one portion. That's for e-commerce. We have also use cases for retail and for FMCG. For e-commerce, is offering the customers an experience, personalized experience, like in an offline outlet where customers can try and see, do an easier return, instant gratification, and in general do an easier shopping. So offer the better choice shopping assistant, for example, or in the middle on the right hand side, the PX360, which is the proactive personalized offering, with the yellow part being the online information and the blue part being the classic client profile, the offline or the structured data, if you wish. Also, what are the use cases that we are using with the natural language processing, the NLP, is particularly for call centers or administration intensive departments like finance, for processing of invoices or processing of contracts. We do the character recognitions and automating the process for purchase predictions, churn predictions, and net presenter score analysis. On the next slide, you will see what business use cases we have for personalized experience in the FSI, financial services industry, for the banks and insurance companies, with personalized journey campaigns, the churn prevention, same as in the e-commerce, digital ad optimization, and geographic behavior of the customers, all with AI, augmented fraud, and anti-money laundering processes that we have done. Also, an interesting one is, for example, if a customer calls and sees his invoice for insurance premium to have increased year over year, he calls the call center and he starts complaining, why is my invoice now higher? Why is my insurance premium more expensive? Then in the call center, usually the consultants, they answer various different answers. What we offer is the call script performance model that does with factoring A and B testing tool that enables actually to classify which of those answers of those particular consultants led to closing more insurance renewal deals. So that's for the second tribe, the PX, or for the personalized experience. On the next slide, you'll see something that sort of rounds up all the experience that we offer, and that is tied to both the use cases, also to new innovation in your organizations, as well as in the data migration or the migration of your analytics department. This is what we do. This is what is our business. So on these nicely looking puzzles, so you see on the right hand side all those technology companies like Microsoft, Databricks, AWS, and many more. Will soon be also the Google cloud services, GCS, that will be part of this landscape. And on the left hand side, you see all the use cases for your marketing department, sales department, creating new interesting important apps for your customers, and processing of the language in voice to text, video to text, etc. And what we do as part of our TechScale platform services that we do for the data science and the AI applications. That's in the middle. That's what we do, the tailored services with an AI suite data frame. So that's in a nutshell from us. We have reserved at the end. We have reserved some time for question and answers. Again, we will send you the deck, but we would like to hear from you. We would like to have your feedback. So please fill in the form. On the next slide, you'll see the invitation. And also, the other surprise is from us, a free of charge. Either you can book a short call, 30-minute, half an hour, 1 hour call, or 2-hour consultancy with us free of charge to discuss your priorities around your analytics data platform or business use cases that you would like us to solve with you. And mind you, one important fact is when you say, or when you have a business case, use case that you want to solve, what we do is we actually help you in the knowledge transfer. We help you to develop it, package it, and own it. So on that note, I don't know how much time you have to do. You can now turn to that particular area. What we would like to know and what we would like to understand from you is whether you are interested in a one-to-one call, whether you're interested but not now, or if you're just interested us to sending you the PDF file. I don't know if there is a network issue, or if you are indeed hearing me. I would be glad to hear from you, either Jan or Oldrich, if you can hear me, if we are still on, or...
Yes, yes. I was just pointing out in the chat that I think I'm not sure if I know I had some stutter on my end. So just to reiterate about being able to book a meeting with us, to have a follow up on discussing your priorities, discuss what you want to do with your data. Let us help you that part, and also to reiterate, like, yes, absolutely, I absolutely agree with Bob. We don't want to do black boxes, so we collaborate on the solution, and we actually want the customer to own the solution, take responsibility for it, use it to its fullest. So I just wanted to reiterate in case there was some interference. So absolutely.
Yeah, I'm trying to see if there are any questions or not. I think okay, you have published like you to. So I would like to thank you all for participation, and we are looking forward to hear feedback from you. We will be sending out your emails, and yes, please let us know your feedback, how we can improve, what would you like to know, what would you like to understand, and if there are any other questions that you have. Thank you very much. Thank you very much for your participation, and on behalf of the entire team, we wish you a wonderful rest of the working week. Looking forward to see you in our next webinar soon.